Here we have the 2019 higher level U value and the mock question. So a total of 60 marks in total, and we're just going to look at each part individually and the best way to approach it. Okay, so you can see here part A is worth 24 marks, so 24 out of that total of 60, which gives you 40% of the question. Alright, so there are a couple of small things to remember. Alright, so if I was going to attack the U-value question in my exam, I'd be looking at immediately writing down the two formulas that I need to remember. Okay, so the two formulas that you need to remember is big R is equal to small r by t, and then you have big R is equal to t over k. Alright, and then that'll make a little bit more sense in a second, but that would be what I'd be writing down immediately to get going. Okay, so this 2019 mock paper, right, so you won't have seen this before. An extension to a dwelling house has a concrete flat roof with an asphalt finish. Right, so the roof is constructed with the following specifications. Alright, so the question will be up on Teams for you there to have a look through. So the first thing, as I said, I would fire down that, okay, because that's going to help you with this first part, and really and truly the first part of the question is it is basically division and multiplication, and then a small bit of addition and then a division again to find your U value. Okay, so that's the first thing I do. The next thing then I'd look at is actually drawing out a table, right? So drawing out a table to put in our thermal data. Okay, so we start off with our layer, our surface. Then we have our conductivity. So that symbol for that is K. Then we have resistivity. So that's small r. Then we have thickness. So thickness is thickness is T. And then, just to make sure for yourself, thickness also needs to be written in meters. Okay. So that needs to be written in meters. And then you have your last column then is resistance. Alright, so then we'll just draw out our table. Okay, this is the same format for every question to get started. Okay, so the exact same. I actually don't know how many layers I have to do. So that's what you would start with. Okay, so making sure you have your formulas written down, which is probably the most important thing. Okay, so then we're going to start by adding in the information that's given to us first. Alright, so the first thing I'm going to do is I'm going to put in all my layers coming down first, then I'll fill in what information is given to me, and then I'll do whatever calculation needs to be calculated. Okay, so that's what I'm going to look at doing first. Okay, so you can go from inside to outside or outside to inside. Okay, so it makes no odds. So I'm going to put in external surface. Right, so the surface itself has a resistance. Then we have the asphalt. Then we have concrete or the screed. Then the roof slab. So concrete roof slab. Then we have internal plaster. internal plaster, then we have internal surface. Alright, and then actually this is fine here, so then we have, I'll always put it over here, total resistance. Okay, so that's the table. Okay, I'm talking through it. How far am I now? 5.5 minutes into it. Alright, so you think now, you know, see how long it takes to go through the likes of this talking through. Okay, so the next thing then I'm going to put in any thermal information that that has been given to me. Okay, so if you look at the question, I'm going to work down along the thermal data first. Okay, so resistivity of asphalt. Okay, so that's what's given to me first. So that's where I'm going to fill in first. So that's 1.250. Okay, I'll go to the next one, resistivity of concrete screed. Okay, so concrete screed is there and it's 0.710. Next thing then is resistivity of concrete roof slab, which is 0.690. Then I have resistivity of the plaster, right, so internal plaster, 2.170. Okay, then I have resistance of the internal surface, so resistance of the internal surface. So internal surface is down here, and it's the resistance, so it's the very last column, 0.104, and then we have the resistance of the external surface there. Make sure it's the resistance you're putting it into, and it's 0.413. Okay, so that's all our thermal information put in. Okay, so we don't have any conductivity or resistivity for that. Same here, here, and here. Okay, what information we do have is we are given thicknesses of these materials here in the center. Okay, so we have the concrete roof slab, screed, asphalt, and internal plaster. Right, so the thing to remember with these is it has to be written in meters. Okay, so it's always going to be given to you in the question as millimeters. Okay, so if you're unsure, okay, so the first one looking at the data on the question is concrete roof slab, thickness 190. Right, so 190 millimeters. So if I want to write that in meters, just handily go divided by 1000. Okay, so that's for the concrete roof slab. So concrete roof slab is down here. Make sure you don't get mixed up now. I had to double check there. So that's 0.19. And you could go if you wanted just to make it a little bit clearer for yourself. Alright, so that's the concrete roof slab. The next thing then is the concrete screed, which is 70 millimeters. So 70 divided by 1000. Alright, so the screed is there. So that's 0.070. Okay, and then the layer of asphalt is 24 mil, so 24 divided by 1000 is 0.024, and then we'll go down to the internal plaster, which is 15 divided by 1000, which gives us 0.015. Okay, so now I have put in everything